Right. So, hello everyone. I'm Ankur Khetarpal, and I'm a senior solution architect with AWS. In this specific demo, we'll be talking about Karpenter and how it's version 2 for a cluster autoscaler, how it makes a cluster autoscaler better, and where it makes more sense to use it. So, probably people who are already involved with EKS are all using some kind of EKS autoscaling. Most of the people already know about how this autoscaling works in Kubernetes, but a little refresher probably may help. So when we say autoscaling, we are typically talking about pod level autoscaling. Uh, and you're probably aware of the first two scalars mentioned here. As the name suggests, pod autoscalers affect just the pods. Horizontal affects the number of pods, and vertical affects the size of the pods. On the other hand, the cluster autoscaler is responsible for ensuring that your cluster has enough nodes to schedule your pods, preferably without wasting any resources. It watches for pods that will fail to schedule and for nodes that are underutilized. It will then trigger the addition or removal of nodes before applying the changes to your cluster. The cluster autoscaler increases the size of the cluster when it finds pending pods that are marked unschedulable. For each autoscaling group, it increments the size of the scaling group to accommodate the pending pods. This is what most of the people are using in their EKS cluster today. Cluster autoscaler works all right for most of the applications and workloads. However, and as Kubernetes and EKS have gained broader adoption, customers are moving a variety of different workloads to EKS, and that's introducing some challenges. Cluster autoscaler relies on the concept of EC2 autoscaling groups to manage cluster capacity. It assumes that the instance types are all identical in a given group. That's how any EC2 autoscaling groups typically works. So to support different EC2 instance types, you need multiple node groups. Also, it is recommended that you have each node group span only one AZ, one availability zone. Therefore, if you want workloads to span multiple AZs, you need a node group per instance type per AZ. So that is why we developed an open source engine called Karpenter. It is a utility that interacts with the underlying resource provider to provide just-in-time nodes for your Kubernetes cluster. Karpenter, like I mentioned before, is an open source, flexible, and high-performance Kubernetes cluster autoscaler. Here are some of the features. It is in contrast to autoscaling group-based cluster autoscaler, it provides dynamic groupless node provisioning. It can also choose the right instance size on your behalf. And as you will notice in the demo, it can rapidly scale your worker nodes. In short, adding Karpenter to Kubernetes cluster can dramatically improve the efficiency and cost of running workloads on your cluster. So Karpenter works in tandem with the Kubernetes scheduler and a cluster's compute provider. In our case, that cluster compute provider is equal to EC2. It is similar to cluster autoscaler in some ways, but very different and better in a few other ways. So for instance, both cluster autoscaler and Karpenter work offer unschedulable pods. But unlike cluster autoscaler, which interacts with the autoscaling and increments it, Karpenter interacts with the AWS EC2 APIs directly. And it uses these APIs to launch a right size instance on your behalf. So it essentially skips a step, whereas a cluster autoscaler calls the cluster autoscaler APIs. Karpenter works with the EC2 APIs. Skipping autoscaling group altogether makes Karpenter much more flexible, and it allows it to have features which were just not possible with autoscaling group based cluster autoscaler. One of the Karpenter requirement was rapid scaling. Karpenter can scale to 1,000 pods within 30 seconds. This was just not possible with the old cluster autoscaler using autoscaling groups. Karpenter's job is to add nodes to handle unschedulable pods, to schedule these pods on these nodes and remove the nodes when they're not needed. To configure Karpenter, you create provisioners. Provisioners define how Karpenter manages pods and expires nodes. Here are some of the features to know about the Karpenter's provisioner. It is implemented as a custom resource, so you're closer to Kubernetes world. A single provisioner can manage compute for multiple teams and workloads. In comparison, you needed a separate auto-scaling group for every little change. You can create a default provisioner, which is aptly named default for common scenarios. You can actually create multiple provisioners for isolating compute for different needs. In this example, you're showing Karpenter provisioner that will allow spot and on-demand instances. And another example which shows ARM and AMD 64 nodes. Using these specs, user can control what is provisioner allowed to do. Here's another one showing what size of instances and availability zones are allowed. As you may notice, for controlling these instances, you can work with the sizes, with families, with generations, and CPUs. You can also control the availability zones and limit where the nodes will be launched. That is all I have for the slideshow. Let me move over to the demo. And before I show the demo, I will go over an architecture diagram which shows what I'm about to demo. So here we have an AWS cloud and region defined, which has an EKS control plane inside it. Typically, when EKS is used, there's a customer VPC where the worker nodes will be launched. Now, when we add Karpenter to the mix, Karpenter worker nodes are launched first, and they act as the seed nodes. You can launch Karpenter nodes as Fargate profiles or a managed node group. In this case, in my example specifically, I'm using it as a managed node group, but Fargate is also an option. Once Karpenter is up and running, any part which is marked unschedulable, Karpenter scheduler will pick it up, Karpenter will pick it up, and it will launch if needed, it will launch a Karpenter managed worker node. Using this worker node will be further used to launch the pods needed. So I'll be demoing what we see here in this diagram. Let me bring up the terminal. So in this terminal, I'll be using two tabs. Mostly I'll be switching between the two. In this first tab, I'll be running a few Kubernetes commands, where I will show what kind of provisioner I'm using and what kind of deployment I'm using. And in the second one, I'm using something called EKS node viewer. Let me show you what that looks like. Right. So I'm launching EKS node viewer where I'm passing a few arguments when I'm trying to say that just show Karpenter viewers, Karpenter based nodes in this view, and watch for memory resource. For the moment, I'm not running any deployment, so it may look a little blank, but as I launch instances, as I launch containers, pods, this will start filling up. It will give you a good overview of what kind of nodes are launching and what kind of memory utilization is happening on those nodes. So let me go over some of the features, some of the examples, some of the provisioner I'm using in this sample. So the provisioner. So I already have a EKS cluster running, and the provisioner Karpenter is already enabled on it. The provisioner looks something like this at the moment. I've added a few requirements to the provisioner, which says just launch on-demand instances for now, and instance CPUs will be anywhere from 2 to 4. And among the instance categories, launch any C or M category EC2 instances. There's another property which I'll be using during the demo, which is TTL seconds after empty. What this property does is that if it sees a node has been empty for defined seconds at this moment, in this example 5, it will take away that node. With that said, let me show you what kind of deployment I'll be doing on it. So I have defined a deployment named inflate, which uses a given which uses 512 meg memory. And based on this memory, it will allocate the resources. And when it sees that the node doesn't have enough capacity, Karpenter will kick in and launch more nodes for me. This is a pretty simple deployment, just to show during the demo that how to create unschedulable pods and let the Karpenter do its magic. So at this time, let me show you how many instances are running. So if I go kubectl get deployments, you'll see I have just one deployment inflate with 0 instances running. So for now, I've scaled it down to 0. But just to show how quickly Karpenter can bring up instances, I will scale it up to 5 replicas. Right? While it's happening, we can bring up node viewer and see in this view how it's going to launch instances. Right? We see that Karpenter has realized that there are a few pending pods, and for those pending pods, it did a right sizing of its own. It found out that an M5A large can fit all these pods, and it has launched that for me. We just saw it changing where it has already bound those pods to this new instance, and it is waiting for it to launch. You can see all this happening if you look at the deployment status. So right now, deployment status says that 0 out of 5 updated replicas are available. And as these instances launch, the screen will start filling up here. Right, the instance is ready, and there are a few pending pods, and you'll see that 5 of these instances were launched. So this was the basic example of how Karpenter can launch instances for you. But one of the major advantages of using Karpenter is its scale. And to show that, we are going to increase this replica count to something bigger than 5, let's say 500. Now, these are a lot of instances. That needs a lot of instances, obviously. And let's see what's happening here. So Karpenter is calculating that Kubernetes is calculating that there are a lot of pending pods left, and it is handing over that information to Karpenter. Now, when Karpenter sees all these unschedulable pods, it's going to launch instances, needed instances for it. While this is happening, we can do the same thing. We can come back here and look at our deployment. And it sees that out of 506 instances were readily available, but the rest of them are going to launch as we go, as the EC2 instances are ready. All right, here we see that Karpenter is launching more EC2 nodes for us. Another interesting thing we can there are more ways we can have a look at internals of Karpenter, which is by looking at its logs. As Karpenter itself is running as pods, we can look at the deployment logs, and it will show us what Karpenter is doing at the moment. So as you can see here, it has launched all these instances for us. And before it did that, it will also show us what all instances it considered. So here, if as an example, you'll see it has considered all these instance types. And among that, it shows a certain instance for us to be launched. Let me go back to the rollout status page. And you can see that the instance is being launched here. If you come back here, this screen will start filling up now. You can see all the EC2 instances launched for us and all the pods running in it. There's just a few pods left. Once that is done, we can move on to the other part of the demo. All right, just pending. So again, this shows the speed at which Karpenter can launch EC2 instances for you. Like I mentioned during my slideshow, this was something which was just not possible with the old cluster autoscaler, which was working through autoscaling groups. Right. It is done with all launching all the 500 instances for us, 500 pods for us. And as you may see, uh, it has launched a combination of instance types for us. Now, adding nodes is one part of an autoscaler. The other part is how it takes away nodes. So we were doing, let's take a few instances away from it. We will change the replica count to 50. Now what this does is it will take away a few pods, and you can see in this EKS node viewer how memory utilization is going down for all these instances. And you would also see this list going down. So if you would remember from what I showed you during the provisioner configuration, there was a property called TTL seconds after empty. So just 5 seconds after a node is left empty, it's going to take away that instance. And now the list has come down fairly well. So it just needed these many instances to run those 5 pods. Now we can know more what happened using the Karpenter logs. So you can see it deleted a node um, based on emptiness. So deprovisioning via emptiness delete, and it took away all these nodes from us. So again, that's the other half of an autoscaler. Now, another feature which was launched recently in Karpenter was is something called consolidation. To demo that, I would have to update the provisioner. Let me bring up the provisioner configuration. An instance, instead of saying take away a node if it is left empty for 5 seconds, I'm going to say consolidate these nodes based on the usage. So for that, I'll come back here and get rid of this property and add a new another property called consolidation. Let me save this. And once you change the provisioner, just like any other Kubernetes Kubernetes type, it has to be applied. Let me apply the provisioner. Right, so I'm going to do its job now, where provisioner sees that there are, when consolidation is enabled via provisioner, Karpenter will periodically check for how it can make efficient use of the available nodes. And it's going to make, and that's what it just did, if you would have noticed. So now the resource utilization is much better than what it was before. And this will help you, this can help users save a lot on their EC2 usage. Some of the one of the things consolidation also does is that if it sees that it can launch a new instance type and have even better use of the available pods, it will take away a few nodes and add a few more. So in this example, it is taking away an M5A large and adding a new C6A large instance. So while it is happening, there is another property or another provision, another Karpenter feature, which comes in handy when you're talking about saving money. That is making use of Spot instances. So if we go back to the provisioner configuration, there's something I mentioned during my slideshow where we can control what kind of capacity type a Karpenter is allowed to launch based on this property here. Now, what we can do is that we can say Karpenter is allowed to launch Spot instances as well. We will save it and apply it. And right now, 50 instances are running and 50 pods are running, and they're already bound to nodes. But if we come back here and change the replica count to 200 this time, Now, for the other 150 pods, for the other 150 uh, instances of or replica of this inflate deployment, we would see what kind of we can notice that now that the Karpenter is allowed to use Spot instances, it is launching those kind as well. And we can know a lot more what is happening internally by looking at the logs. So as you may notice here, it is launching machine and is looking at what kind of uh, for the new set of pods, what what kind of instances were available, especially in there in the Spot fleet. So it will go over all the available instance type, and it will once it can identify, when it identifies that a certain instance type is available among the Spot fleet, it will launch it. Let me go back to the uh, the rollout status, and see if it is done launching all the 200 instances. Not yet. Go back here and see. So you may notice here that it launched a few more Spot instances for us, tackle the extra 200 pods. Right. As it is adding nodes here, you can see that now in our fleet, we have a combination of on-demand and Spot instances. Well, that is all I had for my demo. Hope now we have a better understanding of what Karpenter does and where we can apply it. Thank you.